Note well, if anybody hasn't read this by this time in the meeting, please do so. Once it's gone off the screen here, it will be still on the IETF website.
And many other places as well.
All sorts of other places. Agenda. We are very constrained for time. There's lots of people came in with late documents, or on-time documents as far as their deadlines were concerned, but late as far as us asking for agenda time in this meeting were concerned. So we're going to try and get through this fairly quickly. I would appreciate, as I said on the mailing list, if you could limit your questions to those things that are basically around, is this the right job for a header extension, i.e. the right thing for Avtext to do, and of course whether we want to support the work or not, and there is interest in doing the work or not. If it's something down as, you know, I've got this minor technical problem, don't bother raising it here, do it on the mailing list or save it for the next meeting, assuming we do have a discussion on it at the next meeting. Anything you want to add to that?
That's
Does anybody want to bash? Okay. Working group documents, this says ready for publication request. It is actually in publication request now. The AD doesn't seem to have done anything with it yet, but he's had it 2 days. I don't know what he's playing at.
Well, we're about to have a new AD tomorrow afternoon. So.
Yeah. Splicing notification, we had a late IPR declaration after the adoptions of working group document. So I hope people, I mean, there's been a couple of mails on the list asking if there are any concerns with this. So this is your final time for asking, are there any concerns with this IPR declaration and therefore with us proceeding with this document as a working group document? Okay, if the minute takers could record that no concerns were expressed. Stream pause.
So just to follow up on the previous one, I'm concerned that declarations are coming in late, Colin Perkins.
I think both the chairs are also concerned with declarations coming in late. I mean, basically, ideally, and this applies to the 4 drafts on the table at the moment, please, that we're going to discuss later, please do try and make any declarations you know of at the time when it's still an author draft, so we can actually see those and take them into account when we make the decision as to whether we're going to work on these as a working group draft. It is much easier if we get it then rather than later. Right, stream pause. Had one working group last call. We've had some changes. Is anybody seeing the need for another working group last call on the stream pause document, or are people happy with the document as it is currently now is? In other words, are there any other concerns that people want another review cycle on? So I think we'll just proceed with the getting it tidied up for publication request. Are you going to do that one?
Sure.
Yep. Okay, so if you can make a note that Jonathan Lennox will be the shepherd for that document. That's the pause resume document. Stream pause document, rather, should I say. Yeah, document shepherd. Header extension, do you want to talk about that?
Sure. So on the header extension draft, it was adopted as it was submitted as a working group document Monday morning. We had consensus for the working group document last cycle, but I had neglected to ask the AD for the milestone until I was reminded, so I apologize for that. So this is the plan as suggested by the authors. They're going to update the drafts based on the number of comments they received so far. Of course, if you have, feel free to send more comments to the list or the authors at any time. The details of that, I don't think we need to go through all the details just now, but these are basically reflecting the comments that were in the discussion we had of this draft the last time it was presented. So the expectation is they'll have an updated version of this document in early May, another update before the July meeting, and then hopefully we can go to a working group last call in August or September before the November meeting, and then do a publication request at the December meeting. Anybody have any suggestions or concerns with that timeline?
Just clarification. So there will be another individual version? Or
no, we are working.
The update will be in the.
All this will be as working group. Yeah, it is now a working group document. Yeah, the title at the top is that was submitted with only the title changed and the references updated from the final individual submission version. So, okay, and then.
So, beloved AD, shortly to be ex-AD.
Yes. So, and we have a token of appreciation for the work he has done and assisting us. No, this is continuing the theme we have seen so far over the course of the week. It's simply in a box because it's going to be on the line. Thank you very much. Thank you. What? Oh, sure, have a box. And is Suhas here? Suhas isn't here. Let me move on to the second presentation. What?
So is Suhas here, or someone else who's doing this presentation? Okay, we'll skip it and come back to it then. So if we can go straight to the layer refresh request presentation, let me get it into full screen mode.
I'll be speaking not as a chair in this context, of course, and Keith will do any consensus calls that are needed. Next slide. So the layer refresh request, the idea of this is an AVPF feedback message, which is designed to request a refresh of one or more layers of a layered stream without requiring a full refresh of the whole layered stream as required with the FIR request as currently defined. It's designed to be applicable for both temporal and spatial scalability, and it's applicable to all the various scalability modes which we have with such labor hashed out the names of over the past few cycles. And next slide. So a layer refresh point, as I've defined it, is so you have a receiver which previously only had the state to decode some of the layers of a layered encoded source, possibly none, and so then after the refresher point can decode a greater number of the layers. So next slide, I have some illustrations of this. So for instance, this is a spatial refresh point. It's the idea is, so we've got two spatial layers, which are called S0 and S1. And a decoder is currently decoding layer S0. And then at frame 3, he can start decoding frame S1 because frame 3, S1, there's no dependency on previous frames in that layer. It's only dependency on the lower layer in future. So he can start decoding that without the S0 stream needing any kind of special refresh points. So as we've gone to the second presentation, we'll pick you up when this is done. Next slide. So then a temporal refresh point, similarly, is if you have streams which are referencing, if a higher temporal layer is referencing earlier pictures in the temporal layer, which is valid in most definitions of temporal layers, then similarly, the point at which you can start decoding the higher temporal layer without needing earlier frames of that temporal layer. So in this picture, frame 6 is sorry, the typo on the slide. That should be temporal refresh point, copy and paste, for layer T1. And the next slide. So there's the concept of temporal nesting. Sometimes temporal refresh points are unnecessary if your layered stream has a temporal structure such that it's called temporal nesting, and there's a formal definition of it. Basically what it means is that you don't need temporal refresh points because basically every frame with a temporal refresh point is always safe to switch up. So just to say that, it's possible that you may never need this mechanism if you're doing only temporal scalability with certain structures. So next slide. So the layer refresh message is, as I said, an AVPF feedback message For the details are in the draft. It's a pretty straightforward ABPF message. So what you say is you say that you basically specify the new layer you want, and optionally the current lowest layer you're able to decode. If you don't specify that lowest layer, it means you currently can't decode anything. How you describe layers and how you identify when you've actually gotten the refresh point is codec dependent. But so I mean we've got layer definitions and which are sort of sketchy, just quick and dirty for the 4 codecs we identified that have some form of temporal or spatial scalability. Still a lot of details needed, especially in how you recognize where the refresh points are, because I think identifying layers is usually straightforward. Identifying refresh points is, so you know when you've been satisfied and can start using the layer is often trickier. Any comments so far, by the way? And then the next slide. And then for the applicability to the multi-stream modes, the question for the multi-stream modes is always, could you just use FIR? Send FIR for one of the streams. And the problem I have is, nowhere have we actually specified what FIR means for any sort of multi-stream encoding of a layered source. Does it refresh the individual stream? Does it refresh the whole source? I think there's cases where it would be useful to have a refresh the whole source semantic, at which point saying that FIR just means refresh the stream is problematic. So what this draft is proposing is that FIR, regardless of what scalability or mode you're using, FIR means refresh the whole source, and you use LRR for the refresh an individual layer or set of layers.
Well, can we get to the end of the presentation and then do the...
I think this might be the last slide, other than we want to do this.
Okay.
Okay. Yeah.
Right. Okay. Can I just, before you actually move into the questions, then ask, and I'm going to do this for all the drafts, who's actually read this draft? So at least a dozen. Carry on then, please.
Yeah.
Ronnie Evans. So the last part relates also to the previous slide, because what FIR means is usually specified, like what's the IDR in the
right. So basically,
so you expect to have
right.
such a definition.
As far as I can tell, H264 SVC, which only wants the published RFC, didn't say what FIR meant for the multi-stream modes, and nothing else is actually a published RFC yet. So hopefully we can fix it for the rest of them.
Just Bernardo Boba, just a general comment, right? At least typically for temporal scalability, it doesn't make a lot of sense to send an FIR for an extension layer, right?
That's certainly true, yes.
Right. So in some sense, it's kind of an irrelevant question, because you'd send it to the base SSRC, and that would
yeah, but I mean, yeah, that's fair. Yeah. So it's but I think most people don't tend to do multi-stream temporal scalability as much anyway. I mean, I don't know. I mean, you guys seem to be the most multi-stream guys. So how do you tend to do? Does everything actually a separate stream?
Yeah, everything's a separate stream, but the iframe would only be on the base layer, so that would be the only thing that you'd send the FAR to.
Okay.
Yeah.
Okay.
But I'm not really in love with redefining how existing stuff works. I mean, it's fine if you want to do a new draft, but
yeah. Well, I mean, I guess like I said, the main thing is that I don't actually know how existing stuff works, and if we want to say that FIR means refresh the whole, I mean, look at that. If you're just doing temporal, it's probably 6 of one, half a dozen of the other. It's for multi-stream spatial that I get confused.
So I did have a little bit of a question about that. So, you know, in the diagrams you're showing, I guess I wanted to understand exactly what you wanted to have happen. Did you actually want an IDR frame to be sent in response to this thing?
No,
right?
what I want is for it should not be an IDR. It should be the whole point is to avoid having an IDR.
Right. Okay.
The point is to have a frame. So like for temporal, turn on temporal nesting if you weren't previously doing it. If you were previously doing it, you're happy. You know, you can ignore these messages. For spatial, only reference the lower level pictures of this frame. Don't reference earlier pictures of this spatial layer. That was the picture on slide 3 or 4, or whatever that was.
Ronnie, so there's no assumption about what was the state of the lower layers in terms of the decoder, whether they are available, or
Well, no,
what
so,
it
I
is?
mean,
Because it can be like for a late joiner to this.
Yeah, so the assumption is, I mean, if you send a message that says, I currently have layer 0, I want level 1, the assumption is you have level 0. I mean, that's the semantic of the message. It's possible to send a message that says, I don't have anything and I want level 0, at which point what I would expect you to get is, it might be an IDR on the base layer frame, or at least an intra-encoded. Exactly the details of what is or isn't allowed is a little fuzzy for, and it's codec dependent. But so the idea is that the base layer would have enough that you could start decoding from there, and then the higher layers, which are possibly being received by somebody else, could continue uninterrupted, continue to reference previous frames, so all the other senders wouldn't get the full all the other receivers wouldn't get the full bandwidth hit of an IDR. Colin?
Hi, Colin Perkins. So, yeah, I think I'm generally supportive of this. A comment that you would probably should be clear how it relates to the FIR draft. If you send one of these refresh requests for the base layer, and how that's different for sending an FIR. But
Yeah, I mean, I think
there's a bunch of details like that.
Yeah, I mean, exactly. Like I said, what FIR for a base layer, especially in a multi-stream, means, I was unclear about. I mean, so maybe
But also whether a layered refresh for the base layer is equivalent to an FIR. And
I would say it is not. So I mean, that's the point being that the layers you're not talking about can continue uninterrupted. Yeah. And so I probably will need a bunch more pictures, and I didn't feel like doing that much ASCII art.
Yeah, sure. And I thought it unfortunate that you needed to have a codec-specific refreshes, but I suspect that's probably unavoidable.
Well, I mean, the main thing is how codecs talk about layers in terms of like how many how many dimensions they have and how many bits each dimension has is.
It probably is codec specific.
It is, yeah, it is. I mean, it's basically because 264 SVC has quality layers which nobody else has. How many bits each layer takes is dependent, and so.
So Steve Botsko, so the message tells the sender to create a refresh point.
Yeah.
Is there anything we need to specify on how the receiver knows when it's received that reset point? Or is
yes, and I currently have text in there for VP9 because that's the one we were actually working on when we realized this was a good idea. That will also need to be codec specific, just as recognizing when you have an IDR as codec specific.
Mm-hmm.
So so we're so the draft. I currently have sections for 4, like I said, for the 4 codecs I've identified, which have scalability that people care about. I mean, yeah, how that's recognized does need to be codec specific.
Yeah.
And that's actually the harder part, because the details of exactly what is or isn't allowed can have a lot of subtleties in terms of like what is or isn't allowed as a reference frame and things like that.
Right, and that is all detectable by examining the RTP stream. Not
Yeah, exactly. So and it's possible we'll discover that, oh no, wait, this codec you can't actually detect it, so we're going to have to not allow it for that codec. But we're hoping that, I mean, certainly for anything that's not yet a published RFC or in PubRec, hopefully we can figure out how to identify this for all the
Well,
codecs.
arguably you could.
So you put that in the payload type definition.
I mean, you could.
Yeah, so I mean, I think for things that are current, I mean, where it is documentation-wise, whether it's in the payload type documentation, I mean, for anything in the future, it would clearly be in the payload type definition. For anything that's already a published RFC, it would be in this document. For things that are currently in progress, it depends on where they are in the cycle.
Oh, arguably, right, if you send this command and you display what you're receiving anyway, in a short amount of time, the picture will clear up, right? So it's conceivable that even if a codec, if you don't know how to specify how it's detected, it might still actually work.
Yeah, I mean, just like you might get an iframes if you send an FIR, but I'm not gonna.
I mean, there's a lot of ugly stuff that happens on video switches, and everyone just hopes it clears up.
Right. Yeah. I mean, so the point of this is to do better than hope it clears up, but to actually, particularly obviously for layer switching switch.
Okay, so we need to get moving.
Okay.
Does anybody need to speak briefly to any concerns about scope of this document, or whether it is a header extension or should be something else?
A feedback message. It's not a header, it's a feedback message.
Feedback message.
Yeah. Right.
Right. Okay. So I guess the fundamental question, and we'll confirm all these on the list, is there interest? I mean, basically, I guess show of hands, preferably because it's easier for me to see. But basically, show your hands if you think this is something that IETF should be working on, versus no, you don't think something this IETF should be working on, and then I'll be asking after that for a show of hands on interest in actually supporting the work. just to give it some prioritization. So, first of all, those interested in, well, think IETF should be doing this work. About a dozen. Those who don't think IETF should be doing this work. Consensus. And just now for our information, who would be interested in actually reviewing and supporting further work on this document, actually doing some real work on it? Another 8 or 9. Okay?
Good. That was easy. Thank you.
So Suresh, now you're here. You're next. Slides for you in a sec.
Are we 5 minutes past? Over? Accelerate?
Sorry?
No,
Accelerate, are we 5 over?
2 minutes early.
Yeah.
Oh,
Yeah, you'll get your full 15 minutes.
Yeah.
okay. Okay, so this is a video frame marking, a header extension proposal. Co-authors Espen and Suhas. Next slide, please. So the reason for this work is primarily derived from some parallel work happening in AVT Core. Well, actually now it'll be probably a new working group. There's some security architectures that are being proposed where the traditional middle boxes will not have access to media keys, and so the payload will potentially not be visible to those middle boxes that do the actual media switching. And in those end-to-end private media architectures, we need some more critical metadata available at the switch in order to make forwarding decisions possible. So the goal of this work is to have payload agnostic switching. So these middle boxes never ever have to inspect the payload, and they can still perform all of their forwarding functions. Again, mainly because the payload may be encrypted. Even if you're not doing end-to-end private media, if the payload is encrypted, you can avoid the cost of doing the decryption in the middle box for a higher scale. But most importantly is the middle bullet. In these end-to-end architectures, it's simply impossible to do any kind of payload inspection. And that seriously hampers some of the forwarding functions that you need to do in the switch. And so we need something beyond the current RTP headers to make those decisions. And then also a more forward-looking goal is to have the switching function be something that's codec agnostic, truly capable of handling any codec format, potentially even not even knowing what the codec format is, as long as it knows that the format is conforming to these metadata markings. It doesn't even need to know what the underlying codec is. Next slide, please. And so the intelligence in the switch can help to provide cleaner video switching. Typically when these switches operate, they're usually used in an active speaker role, so that when the active speaker is talking using the voice activity level RTP header extensions, when the active speaker is talking, their video will be switched in. And if you do that naively, you won't get it at a clean iframe boundary, and so there may be a glitch during speaker switching. So we need some kind of indicator so that the switch knows when it's able to deliver a full clean intraframe. You'll also be able to have better recovery during packet losses, because today when the switches detect some packet losses, they don't have any information about the context of that packet loss. Did it affect an entire frame? Did it affect leading loss at the beginning of the frame, trailing loss at the end of the frame? So being able to have some more data about exactly the extent of the loss helps the recovery operations. And during congestion, the switch can make more intelligent decisions about what to drop. If there's information about the priority of the packets in that media flow, the switch can make better decisions that affect less participants. And then finally, if you have diversity in the capabilities of the participants, you can drop entire layers towards some of them, and this header extension will allow that. And for the endpoints, there's also a small side benefit of being able to have better recovery, same as in the sense that the switch would have. You can better identify leading and trailing loss scenarios to know when you have full media frames. Next slide, please. Okay, so the proposed solution is an RTP header extension, and it's split into 2 parts. There's a mandatory fixed length codec independent part, and that's what we really want to focus on today. There's also an optional variable length part that's codec specific, and it can be defined for each payload format. We're initially proposing to define the popular payload formats in this draft, and specify what that optional extension looks like for those formats. New formats going forward in payload would be encouraged to define what this blob means for those formats. And we're using the standard header extension model from 5285. So the length that's encoded in that standard tells you whether or not there is an optional part present, and if it's present, how big it is. And then, of course, it'll be negotiated in SDP, so you can figure out whether or not you're going to get this info from your peer. Next slide, please. Okay, so the codec independent part that we want to focus on, a few flags and then an identifier. So the first pair of flags are start and end of frame, and we'll talk a little bit more on later slides about why some of these are important and what the relation to current RTP header fields are. And then the next pair, independent and discardable frames. This is talking about what the encoded media frame is, whether it's what's traditionally been called an iframe or a keyframe. We're calling independent here to make it more general. But basically this means that this frame doesn't depend on anything that came before. And discardable means that this frame can be dropped without any kind of impact on the decoding dependencies going forward. The next two, are for temporal scalability, which was just presented on. This is the base layer sync indicator. Lets you know when you can effectively resynchronize to higher enhancement layers. And the temporal ID is similar to the temporal ID that Jonathan was talking about. Next slide, please.
One quick question. So when would the discardable bit be set? Is that redundant with the temporal or the layer ID being greater than 0?
No, because this means truly discardable in the sense that it would be the highest enhancement layer. So this means discardable for all layers. There's two interpretations of discardable: discardable for the whole flow, or discardable for this layer. And there's, some codecs make a distinction between those two things and have ways to signal it. And we could explore whether or not that's something useful to signal here.
So Stefan Wenger, 2 comments. One is it is entirely legal and useful in some scenarios at least to have, for example, a discardable base layer picture. Happens, yeah. So don't get too much into this MPEG-2 type of thinking. It's over. It's done. It was done 10 years ago. Second comment is you have absolutely no space for any extensions in there. I would suggest grab another byte, call it reserved, and just to be future-proof. Thank you.
Well, but by the time the work is done, maybe it'll be. There's no desire to keep this limited to 1 byte.
Yeah, and if you can put that comment to the list, maybe, because I think that's outside the scope of what we want to do today, which is decide whether to do the work or not.
So quickly going through the rationale for some of these things that start in end of frame. Intuitively, you may think, why on earth would you need end of frame? You've got the marker bit. Well, the marker is very poorly defined. It's not reliable. Nobody can really use it effectively. So we definitely need end of frame. And the way that the marker is currently defined, it's actually different depending on the standard you're looking at when it comes to scalable media. And we think that a much more sane and robust definition is just to have it indicate end of frame for that particular layer. So for each layer, you can have this indicator set. And then start of frame is useful to know whether or not in loss scenarios, whether you actually have the beginning of the frame or not, because you can't discern when there's loss whether it was the end of the last frame or the beginning of the current frame that you lost. And if you're at the media level, you can look at the payload and inspect. Usually it's pretty simple within most codec formats to look at the first few bytes and determine whether or not the macro block number is 0 or something like that. But if you can't look at the payload, then you can't do that. You need some other start of frame indicator.
I looked at that marker bit and I was surprised, because what you're saying is that the current usage of how the marker bit, because the marker bit as specified today is for video, that's what it does. The 1, 0 and 1, 1 is the last packet of the frame, and that's how we do.
But-
So you're saying
but- well,
not at the layer level.
not at the layer level, but also not normatively. It says you must not rely, decoders must not rely on this. So here we're talking about relying on it. Yeah.
So it sort of seems that like almost everything that would be in a packetization now is going to get moved to this header extension. Like we're doing the VP9, packetization. Like all these same bits are appearing here, like as well. So I wonder if like it just makes sense to take the entire packetization, this entire payload header and stuff it into this extension.
Well, the goal of this is to abstract out what's common among all the payload formats, and that's critical for media switching. What's a critical function for a middle box that's delivering switched?
But you have codec-specific info.
Yeah, so I'll answer that question. At least for H.264, the answer is definitely no. You don't want all the crap that's in there in this extension. It would be worthwhile, I think, as part of this exercise to go off, for example, stuff like VP8, which is, and why you need it or don't in your SFU. But I do think that, but that would, things like the key IDX, I would personally argue that certain fields are needed that are missing. But I think, that would be, we do that after we decide to work on this.
Can you quickly do your last couple of slides and
Yep.
then we'll get to the discussion?
Sure. Go ahead. Next slide, please. For independent, we've already covered it. It's to allow clean video switching at intraframe boundaries. Discardable, we've already touched on that. To drop packets whenever you have congestion with the least disruption to the video quality. Next slide, please. The temporal ID, if you're not in scalable media, this would always be zeros, so it wouldn't be used. But if you have defined hierarchy, you're using temporal scalability with a well-known defined hierarchy, then signaling this would be very useful for middle boxes to be able to peel off individual temporal layers. And signaling may already provide some part of this if you're using something like MRST. If you're using MRST or MRMT, these might already be coming on different SSRCs, and there may be signaling means to associate those SSRCs with what layer they are. So in those cases, it may not be needed, but in SRST, you would have no easy way to discern that without having something like this. And then base layer sync is useful for being able to, once you have loss and you need to recover, when you can start forwarding enhancement layers at a point when you know that the base layers have been synced. It's kind of a hard point to convey quickly here in the few minutes, but I think people that know the VP8Y bit, it's essentially the same thing as the VP8Y bit. Next slide, please.
I don't think you need to present this one, do you?
Yeah, let's skip the codec.
This is detail, you don't need.
Yeah, let's skip the codec. And they're actually
It's
not.
there, that's all you need to say.
It exists. It exists, yeah.
Right.
So that's it.
Yeah. Right, who's read it? Fewer. 1, 2, 3, 4, 5, 6, 7, 8, 9. Any concerns on scope or whether this is the right solution as in a header extension? That's basically what I'm interested in now.
Jonathan Max, an individual. My one concern is, while this feels pretty solid for temporal scalability, it feels a little underbaked for spatial. And we could talk about that some offline, but I feel like I don't have a clear notion of whether this would do everything I need for spatial, whereas for temporal it feels very solid. So
I agree, and it's mostly because it could be abstracted out. The codec agnostic part of spatial scalability could possibly be extracted out, but it's a little more nuanced. Temporal scalability is uniform across the board. The only difference is VP8 is 2 bits, everybody else is 3. That's the only difference. So you give 3 bits and everybody's happy. Spatial and quality scalability are a little more confusing because in 264 you have 7 bits and they're partitioned hard into 3 and 4. In 265 it's not hard to partition, it's 6 bits. So it's harder to get uniformity on that aspect. And I think it's less used, so less bang for the buck when you look at these switching operations.
Yeah, so
I'll
Bernard,
cut the line after
I
college,
more or
just-
less agree with Jonathan that the temporal stuff is well understood. I think to really get down into this, you have to go over a lot of specifics about how implementations really work, what they use, what they don't use. But it's a good start, and there's no claim it's done yet. So we'll kind of have to have the discussion, probably go over the in and outs of various codecs and what is used and what isn't, and also, frankly, what feedback messages are used and what aren't. But
Would you prefer to do that as a working group document or as an author document? Would you prefer that that discussion took place while it was still an author document, or would you
I
like
think
happy
we
to move
can
to a
adopt
working
it
group
with the
document?
knowledge that, we'll have to hash that out like anything else.
I'd agree it's a good
Line
start.
is cut, by the way.
Okay.
That line is set.
Steve Botsko again. I agree it's a good start. I'm not real keen on the codex-specific information field. I do see a connection here with Jonathan's draft because you could also have a refresh point bit in here if you had another bit. I think it would be a good working group item.
Hi, I'm Colin Perkins. I agree that if we're going to do the sort of private cloud switching stuff, then we need something to solve this problem. And I think this is one reasonable way of solving that. It looks like some of the discussion regarding the switching stuff may involve changes to SRTP. If that happens, then exposing some of the payload headers in unencrypted form would be an alternative way of solving that, which would perhaps be lower overhead. Now, I don't know how that discussion is going to pan out, but it seems that we should perhaps have some of that discussion before making a decision.
That's a possibility,
which
but
approach to take.
that's a possibility, but the authors would explicitly like to go in a payload agnostic forwarding direction. So even if it wasn't for the private media architectures, I think it's even a more fundamental goal of this work to make the RTP forwarding function independent of the payload format. And so extracting codec specific payloads for the private media work seems like it's a possible solution, but it seems like it's not the solution that gets us going forward with new codecs.
But if the
The
goal is
line's
to be,
cut, I'm afraid.
but if the goal is to be codec agnostic, then I would be pushing back against having the codec specific extensions here.
All right.
Definitely open to that.
I think we need to get to the questions. I'm going to ask it anyway, but I think there's a bit scope for a bit more discussion on the list on the actual scope. But I'd like to get a viewpoint and what the support is in the room for doing the work. So same questions as last time. Those who think this is something that IETF should be working on versus those who do not, and then I'll ask for interest in supporting the work. But I do expect to see some more discussion on the list on the scoping. So those interested in those who think IETF should be doing the work, put your hand up now, please. 12, 15, 16, 17. Okay. Those who do not think IETF should be doing this work. Those who will be interested in supporting the work by reviewing and so on. 12.
Hi, Colin Perkins. I think there's a slightly broader question. I think the IETF should be doing some work in this area. I'm not 100% convinced this is the right answer.
Yeah. So I think what I'm expecting you to do, Colin, is post that to the list to sort of initiate the discussion. Is that something you can do? I mean, basically that's what I want to see on the list is what is now the real scope of what we're trying to do and so on. What are the constraints on that scope so we can actually know what to write in the milestone.
Very quickly, I just checked something here in real time. I think video has IPR on this stuff. So I don't know whether you want to reopen the voting based on this information. I will verify that, and then
as I
we'll
say, I'm going to
declare and
verify all
probably
these on the
declare
list.
with our usual terms.
Yeah. So maybe you could consult with.
I don't do this type of stuff in real time. I have to draft up a claim sheet. I can't do that.
Maybe you can sort of talk to Jonathan and see what whether there's something that ought to be made. As I say, I will be reconfirming these on the list anyway. So. Yeah. Okay. I think it's phone next, isn't it? Reference picture verification.
This is Ben. So the question on that last one, did I hear that you plan to ask for a milestone for it, but you need to work on the scope, or that you're going to work on the scope and then decide on the milestone? The first?
I think I need to know what the scope is before I decide on the milestone.
Okay, the second.
Yeah. So there's a bit more discussion on the list. What I'm seeing is broadly people in the room want to do some work in this area. Right, we now need to work out exactly what it is. So who's presenting this one? Bo. Is he here?
Yeah, he's here. He's hiding behind him.
Do you want to present it?
Do that. You have to stand in the box.
Yeah. What happened to full screen in this one?
Is it PDF?
Yes. Control. There we are.
So, my name is Bo Burman. I'm presenting this about reference picture verification information. And that is again things that you want to handle specific codec. So next, please. There is IPR multiple on this one. Next, please. So the motivation for this is that with modern video codecs, you often have multiple reference pictures that you can use for improved compression, and you can also use it to recover from decoding errors and packet losses. For example, the HEVC codec has also a possibility to include a decoded picture hash information to really verify that you decoded the frame correctly, which is usually left out since previous codecs. It's not a per pixel exactness measure, but here you have that. And this message is introduced to enable the use of these features, having a controlled way of referencing pictures that may be lost and also checking the correctness of the decoding. So next, please. We propose to use an RTCP feedback message to enable the communication of this information from the decoder to the encoder. You can indicate multiple decoded pictures that are to be used for reference, or indicate that a specific picture was not decodable, maybe because of loss. You can indicate also that a specific picture was decoded but with an incorrect result and thus should not be used for reference. And you can also explicitly include this decoded picture hash for the encoder to evaluate whether this was correct or not. Next, please. There is some relation to existing feedback messages. The most obvious one is the RPSI and RFC 4585, the AVPF. But there you only have the possibility to indicate a single picture, not multiple. That one, or AVPF, also has the picture loss indication, but there you only have the possibility to indicate that pictures are lost, but not which, and specifically not which of certain reference pictures. And there is no mechanism to indicate the incorrect decoding result. So next, please. That is very short presentation.
Good. So let's see if we can keep the discussion equally precise, concise. Who's read the draft? 3, 4, 5, 6, 7, only 7. Anybody want to speak to whether this is the right solution, i.e. header extension, versus anything else, or, sorry, feedback messages again. I'll get this right soon in this terminology.
Bernard about Microsoft.
On the scope. Bernard, please.
And this is just more of a question about relevance. You know, having done a little bit of asking around, it turns out that RPSI is typically not used in conferencing scenarios. And I'm just wondering here if you're thinking of this more as a person-to-person kind of a thing or a conferencing thing.
Yeah, that is the idea, that it's an interactive scenario, yes.
No, Zanetti, and the direction that we've looked at, for, especially for conferencing, is more about exposing RTP level data instead of codec level data. So things where you surface codec level frame IDs and codec level dependencies between those frame IDs. Some implementations have gone in a different direction to only focus on RTP sequence numbers and the delivery of those. And if you look at the congestion work that's being done, it's very likely that we'll have ACK vectors and things like that for reasons, mostly related to congestion control, but could also be used for, for recovery and repair and resilience. So I'm inclined to think a better direction is to go towards RTP level repair rather than deep codec level surfacing of those codec specific values up to some other feedback messages or headers.
Colin Jennings, just given how much we've had feedback messages of various types over the years, and that there's not all that much optimization of combining them together in the same way, I'd prefer to see us pursue something like this that wasn't as obviously IPR encumbered, and see if we could find a royalty-free sort of version of it. It seems like an area where we easily could.
So this being do what? What was that? What in echoing Mo, or were you actually saying do something different?
I'm suggesting the working group should find a non-IPR encumbered solution to this problem if they can.
Steve Botsko, another question I have is really, in order to actually use this at the source, the information has to get there very, very quickly. Right? In some scalable scenarios, maybe quickly is longer than if it's not scalable. But I think one of the reasons messages like this haven't been adopted in the past is that by the time the message gets to the encoder has no real good way to repair a frame that was lost 10 frames ago.
The same problem would be there with RTP-specific information, NAC vectors and such. But
I wasn't arguing in favor of...
No, yeah. Just noted.
Magnus Westlund. So I mean, one reason it might work more these days with the more modern codec is that they have bigger frame buffers and more depth and actually can look further back into history. So you actually still have your old reference pictures in the buffers, so you can actually reach back and use them when you're repairing, rather than having to do an IDR to repair the loss.
There's theoretical and what you can actually do if you're using third-party encoder hardware.
So the chairs here are sort of debating whether we actually put the call now or not. Yeah, I think it would be useful to find out whether people think we have a problem that needs to be solved. But I think that's possibly as far as we might go now.
Which might mean we need a clearer definition of what the problem is that this solution solves, because I don't think this draft I didn't feel like this draft, at least certainly not the presentation, I don't recall the draft, sort of explained, what the use case or models was where this would be a useful thing to do.
Yeah. The motivation slide was not clear enough?
I mean, like all the things we were talking about, like, the round trip time issues and the, it's just, HEVC has this feature, so therefore we want to use it. I mean, what is the scenario in which this would be, what is the network topology, what is the setup, things like that, why this would be the best useful thing to do.
Bernardo, just a general comment, though. I think it's important to take into account the comment that Mo made and kind of what's behind it. We're having an explosion in video codecs. There's interest in privacy. All that tends to lead to away from solutions that are very specific to certain codecs and are incompatible with privacy, right? If we're going to add DALA and VP9 and VP10 and H.265 and whatever, you don't want to have a zillion specific messages that only work with one specific codec, right? Nobody's going to want to implement that stuff. So that's kind of the general context here, and maybe that explains the lack of enthusiasm. It certainly does on my part, especially when I looked at all the feedback messages we have and discovered that like half of them aren't used by anybody anymore. So inventing yet more stuff that's future legacy, I'm just not real happy with.
Let me just comment on that this is definitely not intended to be codec specific. It can very well be used codec agnostically.
Right.
Sorry?
So what we'll do is we'll do a quick call to see between whether there's interest in working on this now versus do we taking another round of discussion as an author draft and see where people want to go with it. So basically, yes, we think this is a working group item now, we want to get working on it, versus I think we need some more discussion on this, take it to the list and see where we go with it from there. So first option, who wants to actually start working on it now? They think this is the right thing to do. Who thinks it needs another round of discussion to decide what we should be doing in the working group? Who wants it to go away completely? Right. Okay, so I think basically progress as an author draft, see where you want to go with it, have some discussion with some other people, maybe persuade them round. Okay? So, Peter. Control L, was it?
Okay, so I'm proposing a header extension that's like the MID header extension, but for multiple layers instead of multiple media sources. Next slide. So we have three different things, or three different layers. Within our taxonomy, we have media sources, we have encoded streams or dependent streams, or in other words, different layers within a media source, and then we have different RTP streams. So media source can have n layers, or encoded streams and dependent streams. Each one of those can have 1 to 3 RTP streams, RTX, FPC, or neither. And before, we could always use payload type for all of them, but payload type has problems in the sense that you can run out. Or you could use SSRC for everything, but SSRCs have their own issues. And so we defined the MID header extension for the class on the top row, which is media sources. And now, if you're not doing any simulcast or any layering, you can just use MID and payload type. You don't have to signal SSRCs, and you don't have to worry about running out of payload types. But if you are doing simulcast, or you're doing layered encoding, there's a missing box there.
Hi, Colin Perkins. I'm kind of confused because you can't use payload type for half of these things.
Why not?
Well, I mean, media source is identified by the SSRC. The RTP stream is identified by the SSRC. If you're using the payload type to do that, you're doing it wrong. That's just not how RTP works. I'm sorry.
Well, payload type has before been used to demux and identify all three of these things. And so has SSRC.
No.
I'm not suggesting this is a good idea. In fact, I'm suggesting the opposite, that MID is a good solution.
So this is not true. What is being used is the SSRC is being used to demultiplex the streams, and the payload type is then being used to identify what type of media it is.
Okay, so that's a fine distinction, but...
No, it's a very fundamental distinction into how RTP works, because the SSRC identifies the source, the sequence number space, the payload type space.
So what I'm trying to get at here is that we have a solution with MID for making it so we don't have to signal the SSRCs, and we don't have to rely on the payload type being a demux point that identifies everything and having the potential for running out of payload types.
I realize it's a bundle. I just believe the slide is incorrect.
All right. Well, send me an email with some details of how I can fix the slide. I'm sorry if it's slightly incorrect. Take the what? Okay. Well, I left them out of the original slide, and someone told me to put them. So
I think just to add to what Colin is saying, that on the RTP level, its demuxing is based on SSRC. I think what Peter is saying is how do I map that stream to SDP is done through some of the mechanisms like MID and things like that. It's not at the RTP level.
This is kind of immaterial to where I'm headed with this.
Right. So get where you're heading, please.
MID, it's kind of a mess, and MID cleaned up a lot of that mess for bundle, where we have multiple media sources over the same network port. But now we have the same problem for multiple layers within the same media source. And so there's kind of a missing thing for the box. So what I'm proposing is, next slide. Now we fill in the box with a header extension that identifies the layer. And honestly, this could potentially be part of this other header extension where we have a temporal ID, but instead we put in a spatial ID. But they didn't have a spatial layer ID in theirs. So if we don't have anything anywhere else, I'm proposing that we have a header extension where we can specify an ID that indicates the layer, the spatial layer. And that could be called an encoded stream, or it could also be for a dependent stream. I chose to call it ESID, but like I pointed out here, it could be LID for layer ID or some other thing. So if you can go to the next slide. The benefit is you don't need to signal SSRCs. There's no risk of running out of payload types, which were the same problems that we overcame with MID, except now for multiple layers. And this could work in conjunction with the work that's going on in InMusic, where they're trying to define how to do simulcast in SDP by overloading FMTs, but you might run out of those. So this could address that problem.
So, Magnus Westlund, I think you started in the wrong group. I think you need to go to MMusic and actually discuss what type of configuration identifiers, etc., because that part of this work is actually more relevant. I mean, putting in a header extension and getting which is basically what Avtext has scope for doing, is trivial. What's the big question here is, can ESID be signaled in the SDP in a reasonable way to actually mean what you're suggesting it to mean? And I mean, I want some solution for simulcasting, identify the kind of the configuration of the encoded stream, and payload type isn't enough from my perspective. So yes, I in that sense I support the work, but I think we need to start talking it rather saying, how does this look in SDP, rather than being here and discussing it. So.
Right. So there are two
Can we
parts.
cut the line there, by the way? No more in the line after Colin.
There are two parts to the solution.
After Ronnie, rather, sorry.
One is to define the header extension, which you point out is fairly trivial. And in fact, I just copied the text from the MID header extension and renamed some things, and that was that part of it. And I actually think that part of it is useful all by itself, and I would be happy if we just had that for scenarios where we want to use this header extension outside of the realm of SDP, which is still valuable. The second half is how do we map it to SDP for those who want to use SDP, and how do we define that? So the second half of the draft is defining a proposal for that. But you're right in the sense that this might not be the right working group for this. Maybe instead we define the header extension here, and then the MMusic group can take the header extension and incorporate it into one of their drafts for the work on simulcast within SDP. So I agree with you that half might not be right for this group.
Emil, so I think this is a very good thing. I very much support this work, and we have that problem today, and I think that's a very reasonable solution. Now, as to whether or not some part of that has to happen in MMusic, probably. Some part of it has to happen here as well. So I don't see why we have to block the part that's happening here, waiting on something to happen in MMusic. It's not the fastest working group in the world. So, just a quick question, and you can feel free to answer, read the draft. The ESID in a scenario with, let's say, a conference with 10 participants, that doesn't have to be unique for every participant, right? It can be the same ESID used for the same sort of stream for every participant, right?
I was imagining it'd be his application choosing it, so yeah, you could.
Right, you could map the same to every.
Right.
Right. Okay.
Or you could have them be different.
So Colin and Ronnie, if you can keep your remarks brief, as you're about to go over time. So if you can try and be as brief as possible, please. As we're about to go over time.
I'm Colin Perkins. I have no objection to defining identifiers to correlate to different streams. I think that is generally a good idea. I have strong objections to the way this particular draft works. I think the way it overloads the SDP format parameter is completely and utterly broken. I think the way it attempts to extend payload types is completely and utterly broken. So I would object in the strongest possible terms to this draft, although I would think the general idea of correlating streams is something that's worth considering.
So can you, I wanted clarification on this. So if there are two halves to the proposal, one is the header extension, one is the SDP, you're strongly opposed to the SDP part. What was your feeling on the header extension part?
I am strongly opposed to the SDP part and overloading the format parameters in the way you're doing it.
Okay, I understand that, but the header
The
extension
header
part.
extension itself, as Magnus has said, is utterly trivial. It's the way you assign the identifiers which is problematic. Once you've figured out how to assign the stream identifiers, then wrapping it in a header extension is trivial.
So you'd be okay with having a header extension?
I am okay with the concept of a header extension for an appropriate identifier. That bit's trivial. I think the particular identifier you're proposing is broken, fundamentally.
So what you're saying is that you see no value in the header extension if there's no SDP mapping.
No.
He's saying you need to define the appropriate identifier and get
all.
agreement on that before you go to the header extension.
An appropriate...
I identify the identifier as ESID.
Yeah, but I think Colin's saying it's inappropriate.
I think your
Maybe
ESID
right
proposal is completely broken. Once you have defined an appropriate way of identifying these streams, then wrapping it in a header extension is trivial. But the mechanism you are using to identify the streams, the identifier you've chosen, does not work. So once you have identified an appropriate identifier, then sure, we'll come into a header extension. It'll take 10 minutes to write the draft. That's not the hard part.
Right. So, Ronnie?
I agree with what was said before, definitely, because
You agree with Colin?
header extension doesn't make sense without the other part, because you said it should not be unique. It depends on how you define it in SDP, because the way you define it now in SDP is not unique, but if you define it differently, it may be needed to be unique. So it's until you go to the SDP part and define how it's being used, there's no reason to do this header extension. Well, by the way, we had this before. We had this before in the application ID. That's what we tried to do when we had the application ID.
Right.
That's the part that I disagree with. I believe there is value in this without having a map
but
from
I mean, what I'm saying is that
separate.
in the way you've actually scoped the problem at the moment, sufficiently people are coming up to the mic saying, we don't believe this is right, that you basically need to go round the loop and basically have another look at the problem. So basically that's what I recommend is that...
I heard two objections to the SDP mapping, and both of them saying that if there is no SDP mapping, then the header extension is of no value.
No, that's not what they're saying.
That is...
Very briefly, Colin, please.
So the fundamental part here is defining what the identifier is to correlate streams. I think the way you have done that is broken. Therefore, the way you have encoded it in SDP is broken. Therefore, the way you're encoding it in RTP is broken, because the identifier is wrong.
If I demonstrated a use case for this that did not involve SDP, and I could demonstrate value...
No, I think your fundamental problem is the identifier.
Yeah, I'm not...
No,
I'm not...
What I'm saying is if I could demonstrate a use case where I'm identifying...
I think you're missing the point.
No.
I am.
I am not objecting to your use case. I understand your use case. I think the use case is important and needs to be solved. I think the particular solution you have picked is broken.
Yeah. So I think this has identified people you need to go and talk to. You don't need to wait till the next meeting to respin this problem.
Right.
Basically, get them on your side. Maybe that will identify that you actually need to go and do some end music work as well. Take the opportunity here to talk to the end music chairs, possibly in conjunction with other people, and see where you go next. But I think you're basically going to have a respin of the draft so that it actually more clearly says this is something that is valid, and this is the header extension that encompasses that thing that is now valid.
Well, can we go to the question?
I just have one little comment, which is maybe I'm having a hallucination, but I think everything that's in this draft, or at least all the header extension stuff, could go in the frame marking and be entirely useful there.
That's what I was saying.
Also, I'm not hallucinating alone. Good.
I mentioned that earlier, which is, they have all these bits for everything except for...
Yeah. Well,
I'd be totally happy with that.
I think we need to make sure that people are actually happy with the thing that's being shoved in. That's basically the problem. Yeah. No. Okay, more discussion on the list, basically. More discussion offline.
Can you skip to the last slide?
Well,
no, the very last slide.
So
basically, I would like to know, the very last.
Very last slide. I haven't got any slide numbers, so I'm...
I would like to know from the working group as a whole whether they think even independent of SDP, if it's worth having a header extension.
I don't think we've reached that point yet. I'm not seeing sufficient support in the room yet. I'm seeing some people.
Well, we had one person offering
yeah.
support.
So I'm not saying we're killing this. What I'm saying is you need to go around and respin the discussion.
Okay. Is there? I'm just wondering if anyone else is interested in the header extension, independent of the SDP, or.
I don't think anyone is objecting to the header extension. That's not the problem here.
Right.
The problem is not the idea of putting a header extension to correlate streams. That's a wonderful idea. The problem is the particular thing you're trying to use as the header extension, the particular identifier you're choosing.
It's just a number that identifies the encoded stream.
Yes, and the
You've chosen a number that represents apples, and he's saying that it should be a number that represents oranges.
You have chosen to do it in a way which overloads the format parameters.
Forget that part. Just forget about the format parameters.
That's the important part.
Right. Yeah. The chairs have a more fundamental problem that we are totally out of time.
That could be used without SDP.
Yes. Right. So.
Okay.
Right. Meeting closed.
All right.